Hello, my name is Riley Brown, and I'm back with another computational geometry program. So this one is my counting triangulations program, which implements a dynamic programming approach to finding the number of triangulations in a polygon. I wasn't able to find a specific attribution to who discovered this, so I will simply note I learned about this from Stony Brook University. Their computational geometry course is AMS 345 or Computer Science 351. If any of you are going there, it's a great course to take. It was taught by Professor Joseph Mitchell, and he taught us about this approach to find the number of triangulations. One of many approaches, but this was one of the more algorithmic approaches in order to be able to code rather than just using some sort of inspection, a hard-coded manner for finding the number of triangulations possible in a given polygon. So let's start by just inputting polygon, just as we did with the other programs. And so we just hit continue, and it's going to calculate it for us. So we have a giant array, right? So it instantiates an array, and basically it operates off the idea that we want to find the number of triangulations to the left of a given directed edge. So it's not just, so like even if you look at the table, right? So if you have, it's not a diagonally symmetric. Part of that is because in dynamic programming, we're not going to do every single element in our array if we don't need to. You know, it's just a lack of efficiency. So sometimes the zero is there if it was not used in the calculation. But other than that, still considering it is far from the directed edge is essential in making this all happen. So essentially, we find the maximum in this array. So that maximum is going to tell us what the total number of triangulations, right? If there is any edge in this for which we can have that number of triangulations, we know that's the final answer. So and generally we purposely select this edge, right? Because we don't want it. So like if we did everything left of 6, 7, right? So if you follow my mouse, sometimes when it renders the video, the mouse is in a little bit of a different place. But we have this 6, 7 line. It's not going to encompass the entire polygon. Whereas our element that we are looking at, we've got 4, 5. It's 386. That does encompass everything. So 4, 5. Yeah, so part of this is going to be a little bit tricky because of how Java renders its images. So it's kind of almost flipped. So we have, this is 0 in the x direction, and then that's whatever, 400, and then we got 0 in the y direction, positive upwards. So the notion of left is operating off of a more traditional plane going this way. So that's why we're going to have our 5 this way rather than maybe a more traditional array would show that. Anyways, so that's why it's column row. The entire shape is encompassed by this. So we look, okay, what's everything left of 4, 5? Well, we're going to add up everything to the left of 6, 4 plus everything to the left of 3, right? And that is going to give us our 386 figure. Yeah, so that's kind of how the program is used. And that's a little bit of the background on the algorithm. It's obviously far from a perfect explanation, but on my GitHub there's the full. It's all open source, so it's all you can see in the simple polygon.java exactly how that algorithm works its magic. So that's the program, and that's how you use it. It's pretty straightforward. You input your polygon, you press continue, you look at the table for some enlightenment on how the inner workings are, but it's going to give you right at the top right here, that number, 386. So I hope this was helpful in demonstrating that dynamic programming approach, and hope everyone has a great day.